Welcome back, technocrats. Here, in the last class, actually, we discussed about the theory of Farasis type induction, which is used in the making instrument. There are the two poles connected with non-inductive resistance, and two pole is connected with inductive coil, which provided the some angle between two flux, and where we work for this the direction of rotation of the field like this, and the two force are generated for force F, which is acting in this direction, is proportional to phi L, which is inductive coil flux with ED current resistance, and in this where the force F proportional to flux by the resistive coil and the eddy current produced by the inductive coil in the drum. And we can check here the phi L ILR is the direction of the rotation of the rotating field, and the proportional to the phi R IL in the opposite direction. Both the flux phi R phi L are assumed to be decreasing. So from Lenz law, IR and IL induces in the such direction that they tend to maintain the flux. The direction of the force producing acting on the drum are obtained from the left hand rule. Resultant torque is the difference between that due to phi L IR and that is due to phi R IL. Thus phi R phi L and IR IL R is the RMS value, and the mean torque is given by Tm is equal to K phi L IR cos 90 plus alpha minus beta, and minus phi R IL cos 90 plus alpha plus beta, where K is the constant. Also you can work K is equal to K uh, Tm is equal to K into minus phi L IR cos 90 minus alpha minus beta plus phi R IL cos 90 minus alpha plus beta is equal to K phi R IL sin alpha plus beta minus phi L IR sin alpha minus beta. ER proportional to F into phi R, and EL proportional to F into phi L. This is the frequency. IR is equal to ER divided by Z, and IL is equal to EL divided by Z. Z is the impedance of the eddy current path in the drum. Hence, Tm is equal to K dash phi R phi L by F by Z into sine alpha plus beta minus sine alpha minus beta, where 2 K dash phi R phi L F divided by Z into cos alpha into sine beta. K is the another constant. Again, if phi R and phi L are directly proportional to the current IR and IL, means Tm proportional to IR IL by Z cos alpha sin beta. IR and IL are the proportional to I, or the voltage to be measured, Tm proportional to I square F by Z cos alpha plus sin beta, means I is the root mean square value. The torque is proportional to the mean square value of the current to be measured, means we can work. Now this is the another type, the shaded pole type. For this is the damping magnet, this is the aluminum disc, this is the copper shading band, where like this one pole is this, and one pole is this, and this is like the copper band. This is the copper band, and it makes the short path for the flux. So the ED current produces here is the reduction in the flux. Suppose this is the flux linking this, but this flux is linking with the reduction of this shunted copper shedding bands, and the flux is less, so there is the gap between this flux and this flux, and the generation of the flux in this laminated electromagnet by the exciting coil which is placed here. The copper band is here also. This is not visible, but this is this spindle move in this direction. So we can check here the same principle. We can check the same principle like TD proportional to I square and TC proportional to theta, where theta is the deflection. For the steady deflection, TC controlling torque is equal to deflection torque, T theta the same. Means this is the theory, this is the phi u, and this is the phi shaded. Shaded the means the copper band, this is the without band. Angle between this is the beta, and between this phi u, this is 90 angle, this is the EU developed ED voltage, ED voltage, and for the phi s, this is the ED EMF is the ES, and lagging alpha, this is the ED current IS shaded ring, and for the without shaded ring induced EMF, induced ED current, this is the alpha angle lagging, this is IU, and this is the phi u. Means we can check here, this is the flux entering this side, this is the phi u, and by the Lenz law there is the production of, and this will be the ED current generated from phi u. This is the IU generated in this directions, and IS is generated in this direction. This IS is linking with IS, IS is here, phi u, the B is the down, this is phi u, and this is the F in this direction. We can choose here, suppose this is the, for this point, this is the flux entering this, and the current is this direction, and the thumb, so this is the F, this is I, and this is the B. The similarly for this, and this is the B is equal to phi u, and the force is experienced in the left direction, and this is the direction. And similarly for this is the phi s iu, this is the is, and this is the down direction, and the is is different, and this is the, for this you can check here, this is the phi s direction is down, I is this direction, and then the force is like this is the force, this is the action of sided pole type of induction instrument. Phi s phi u is the RMS value of the mean torque. This is the torque T is equal to K into phi s iu cos 90 minus beta minus alpha into phi u I is cos 90 plus beta plus alpha, when K is the constant. T is equal to K into phi s iu sin beta minus alpha plus phi u is sin beta plus alpha. As theory of Faray's instruments follow that if phi s and phi are the each direction proportional to the current I in the magnetizing coil, and the Z is the impedance of the eddy current part, the torque T proportional to I square F by Z cos alpha sin beta for any given frequency, torque proportional to I square.